ARPU, or average order value, as a North Star metric, right? Why does it make sense? It's true. I mean, you want to use that. So why does it make sense? Well, it is directly connected to business goals. It is easily understood by all stakeholders. It is concrete. It is objective, and it works across context. So you can use this revenue KPI for your all experiments, and you have some comparison across different business models, right? Fair. Now let me quickly walk you through the variability of ARPU as well. I'm going back into my simulation for ARPU, quickly explaining what this setup is. So I have a few controls here on the top. There is a price range, and I have three different options. Small, meaning the spread is $1 to $29, medium $1 to $99, and large $1 to $299. I have number of price points here, 1 to all the way it goes to 10 here. What does this mean is it just means how many price points do you actually offer to the customers. So if you're a subscription business, you may have just two price points, monthly and annually. So just two price points. If you are an e-commerce, you may have different price points like $5, $10 items, $100 items, right? It could be n number of items depending on the SKU. Then I have another control here or factor here called purchase mode, where one user can only purchase once within the 30-day period that I'm simulating here, or they can purchase multiple times within the 30-day period. And then the last one I have is repeating users, meaning you have some chunk of users who are your heavy users who visit you again and again. So what proportion of these are within your mix? So and there is a table here that I show. The first column, the multiple rows indicate is the because of the first column non-paying percentage, meaning you have, let's say, 100,000 users, but then not all of them are going to be paying you, right? There is 10% non-paying, or meaning 90% of people are still paying you, or in the other case it's 90% of people not paying you, so only 10% are actually paying, meaning you have a huge variance because you cannot just like calculate the KPIs for an experiment for whom you for the users who are just buyers, right? Because your experiment could have converted new buyers as well. If you don't account for that, then this whole scenario could be completely biased. So you have to account for all of the users who are part of the experiment, buyers as well as non-buyers, especially in revenue settings or in any of the KPIs. Now let me show you how it's varying here, right? So 10% non-paying, meaning 90% are paying. So your mean is high, but your standard deviation is still relatively low compared to this. So your coefficient of variation, which is just the ratio of standard deviation over mean, is 33%. And because it's low, like 90% of people are buyers, your sample size requirement is much small. As you go down, as your number of non-buyers increase, your sample size requirement increases significantly because there are so many, your mean declines, and also is your standard deviation going to increase at the same time because you're now accounting more people who are not buying into the calculation. So that's why your overall sample size required for 1% MDE is going to significantly jump from 17,000 to almost 3 million for people who are only 5% buyers in your mix. So it's dangerous, right? So you see the factor that immediately affects your ARPU. So you consider what is the proportion of your buyers. Now let me start playing around with this. So number of price points. Let me introduce one more price point. So by the way, in the previous case, I had $15, which is just the average of the min and max here. But let's say I am adding two price points, one, the min and the max. So these are two extremes, and you can see immediately the sample size have jumped quite a bit, even though the users are only buying once. Why? Because now there are more users who could be buying this $29 item, and then there are users who are buying $1 item. So the spread has gone really wide that affects the mean and the standard deviation quite a bit. Especially the standard deviation. As a result, the sample size goes up, and you can see a lot of people are buying, and here it's actually uniformly distributed, by the way. So almost half the users who are buying, and I've selected 70%, meaning 30% of them are buyers, and overall sample size is 50,000. So 7,000 plus 7,000, about 15,000 is 30%, right? And they are uniformly buying both of these. So that's what here's, and it's still in single purchase mode. They are only purchasing once. Let me add one more price point in the middle somewhere, right? So I'm adding one more. So now I have added 18 as a new price point. You see the price actually now it declined, the sample size requirement. Why? Because you've given extra choice for users to choose something that is not as spread out from the min or the max, right? So either most people will buy this or that. In my simple assumption, I have assumed uniform distribution, so that's why you're seeing three equal bars. Likely this may not be true in real world scenario, but still your sample size, you can see it's reduced. And as you increase further and further, you could see that it declines because the you're giving more choices individually in the mix, and users are uniformly buying. In real world, again, this is not going to be uniformly distributed. This is going to be having some different distribution, and it could work differently altogether. But you still see it's not as low as single price point. Let me reset this to just one again, and let me improve to multiple purchases. Multiple purchases meaning one user can buy multiple times within the same time frame, and the mean purchases is 2. Okay, now you see again the sample size has gone up, and now you see start showing you the right skew of the purchases, or the revenue, total revenue, because some users are buying multiple times and increasing the sum on the right hand side. So someone has bought like almost 132 to 153 dollars, like 94 people have bought that. But most of them are still buying less. If I increase this further and further, you see it starts showing you more right skewed, and these are the number of purchases per user. So as this, the worst is the first one that you add here. It requires more, but then as you go on and on, it it kind of moves around depending on how your data looks. Okay, there are many assumptions in this scenario, but this is pretty much very closely to how it would behave within your sample size, or within your data as well. If you have multiple purchases and some of your repeat visits starts coming in more and more, meaning you have heavy users, so let's say 10,000 or 20% heavy users, they're going to buy even more. So you require 192 when there were only unique visitors, but if some of them start repeating more and more, they're going to buy even more, causing the data to look something like this. So very heavy skew on the right, where you have extreme users who are buying more and more. So it just significantly increases again the sample size requirement even for this scenario, right? So this is what I wanted to actually show, why ARPU suddenly becomes a very bad KPI within an experiment setup, because you will never achieve power of the experiment itself. So moving on to the slides quickly, and I will have to rush through. There is also a flywheel of declining revenue, meaning you're trying to measure this revenue as a KPI, but then you don't find winners or losers because it requires long samples. Then you start testing extreme experiments out of frustration, and you end up doing some tests that harming user experiences, which is basically enshittification of the product. There's a lot out there about this as well, and ultimately you end up declining the user itself, which were actually buying more. Now your revenue starts declining more and more, and the flywheel keeps on going and going and going. Okay, so this is how I have personally experienced in the past. And then there is also a good heart law, right, where you are trying to optimize for revenue, then suddenly it starts becoming a bad measure. So whatever measure you are trying to optimize for, it becomes a bad measure, uh, because it's not, because people will start gaming around it, and it's not gonna actually help uh, in achieving that actual goal. So some of the factors to consider: are you a subscription only business? You are still safe if you have very less price points and people don't buy multiple times within a month. Do you have only handful of SKUs? Do your customers purchase just once during the experiment period? Is your buyer conversion rate less than 40%, right? So all of these factors are going to obviously affect your ARPU variability and your sample size requirement.